Hello, it's Duncan. Last week we managed to get quite a long way through designing the types and operations of 10-pin bowling by skipping the tests and just thinking about the domain. Sooner or later though we need to run the code. So today we'll try creating a game, throwing some balls, and seeing how much of our original design survives contact with the tests. Okay, normally to start a session I'd run the tests, and so that I can, I've created bowling tests, but as you can see there's absolutely nothing in them. But let's just run them anyway. There we go, that's all good. Right. Let's just remind ourselves where we finished last time. We have this game, and a game can either be playable or completed. And only playable or completed, so we're representing that as a sealed interface. And a game has a number of lines, and a line is another sealed interface here, which has a player name and a list of frames. And lines can either be themselves playable or completed, and so a completed game consists of completed lines. Lines themselves have a list of frames, and frames, well, they're an interface, and we have a number of different types of frames. We have a playable frame and a completed frame as sub-interfaces of frame, an unplayed frame, an in-progress frame, a strike, and a normally completed frame. Now, two things have come up since I published last week. First is Tim asking why frame is not a sealed interface. And that's a jolly good question, and I suppose it really should be, or alternatively, maybe line doesn't have to be sealed and game doesn't have to be sealed. And this begs the question, why are sealed things good? And the answer is, well, they're good because we can ask questions like when and do an exhaustive match. We know all the different subtypes there can be. Now, we're not actually using that at the moment, so I'm inclined to take the sealed out so that if we have to put it back in again, we get some information. On the other hand, you may be saying, Duncan, you should be expressing the type system as much as you possibly can about this game. And, oh, you've persuaded me. So tell you what, I'm going to undo this one, and I'm going to undo this one. But I'm going to leave the one that is there at the moment. That is to say that frame is not sealed, just so we can see the advantages or disadvantages. The other thing I raised myself is whether frame should have optional roles inside it. And the more I think about it, the less I like the fact that frame has roles, but they might be nullable. So what I'm inclined to do is say that a frame has a score, but not necessarily roles. So we take that out, and then fix it in all the subclasses. So an unplayed frame, well, by definition, that has no roles, so we can take those out. An in progress frame, well, we know it's got a role 1, but it's not going to have a role 2. So that role 1 is not going to override anything, and role 2 isn't going to be there. A strike, well, that only has a role 1, and it's always 10. And a normally completed frame has 2 roles, but they don't override anything in frame. Now, the effect of that change will be that we always have to downcast from frame to a particular subtype of frame in order to see any of the roles. Whereas previously we could ask any frame for its role 1 or role 2, but they might be null to say it doesn't have them. I sort of feel this is a better representation. Your mileage may vary, but let's just check that in. So that's remove roles from frame. Okay, good. There's lots of warnings, but those are largely about the TODOs, I think, that we have in here. Now, bear in mind that this was an experiment to see how far we could get without writing tests. But I think maybe the life cycle would have been clearer had I written tests. So let's get on and do that. How do we start a game? Well, I guess we can say, well, game is a playable game, and that requires a list of lines. Well, that's already asking quite a bit of knowledge of somebody who comes to our API. So let's see if we can do better. Let's move that over there a bit. What we'd really like to be able to do is say, just create me a game. How would we do that? Well, we could make it look as if we could get a constructor for a game by adding a companion object to game and adding an invoke on that returns a game. Let's just do that for now. And in order to work, that would have to be an operator fun. And now this compiles, and users of our game API don't need to know about playable game or completed game yet. Now we've got a to-do here. So what can we assert about the game we get back? Well, I think we can assert that it is a playable game. If we've created a new one, we should be able to play it. So I think we should be able to say, expect that game is a playable game. And now finally, I can run the test and see that it fails because there's to do. Okay then, simplest thing I can do right now is to get this to pass by saying this is going to be a playable game with empty list of lines in it. Does that work? It does, good. The problem is that while it compiles, I don't think a game with no lines in it is actually playable. It doesn't have any players. In fact, thinking about it, when we create a game, we probably want to tell it the names of the players. And a game with no players shouldn't be playable. So I've already got this test wrong. I'm going to say that this is going to be a game with no players isn't playable. And so this should be, it's a completed game. I suppose it's completed. Now that fails, and we can make it pass by saying that this is, in fact, a completed game. Good. And now we'll duplicate this test and say a game with players is playable. How do we get players? Well, I guess we add people. So we'll have Fred and Barney. We don't have parameters to our constructor. We could add them to invoke, but that's not going to make a varargs, which is what we actually want. So let's do that by hand, I think. We'll say this is going to take vararg, player name, or player names. Now, interestingly, that's not compiling. What's it saying here? Forbidden vararg parameter type player name. I suspect that's because player name is a value class. Maybe you can't have vararg value class parameters. News to me, but we actually were passing strings from over here, so string I think will be fine. I do wonder whether player name is worth its own type, to be honest with you. So now that compiles, let's see what happens if we run it. Well, we're answering the wrong thing here. We're always answering completed game. So let's say that this is when player names is empty, then we want to be a completed game. Else, well, we've got some player names, so we want to be a playable game. But what to put for lines? The problem is that Kotlin doesn't have a non-empty list in its standard library, so we can't say here that playable game is a non-empty list of lines, but we know that's the truth. I think for now, let's just get the test passing by saying it's an empty list, even though we know it's going to come and bite us in a minute. So that should at least get the test passing, and does. Okay, what I think I'm going to do next is immediately break the test by putting an init in here that checks that our lines is not empty. Because it's the truth, we can't express it in the type system without adding a non-empty list, but we can assert it at runtime as quickly as we possibly can, and that's in this init. So if we run that, we fail. So then we need to not pass an empty list here. We need to pass a list with as many players as there are player names. That feels like a map to me. So instead here we'll say player names.map. Now we need a line in here, and that's going to be a playable line. What do we need in a playable line? We need a player name and a list of frames. Well, the player name we can get by just constructing one. And again, I think we can cheat here and say empty list for our frames. That will get us to pass. Good. Although we're now playing fast and loose with playable name because we know that playable lines couldn't possibly have an empty list of frames. Before we address that, it is tempting to say that playable game should consist of a list of playable lines, but a playable game can have completed lines as long as it has at least one incomplete line. As we're being all formal today, maybe we should express that in here, so we could say require lines any it is playable line. And that will ensure that this current line here, which is a playable line, must exist. Okay, we should be good, and still are. But now once again, we're going to go and break things by going to playable line and saying that that must have some frames. So we'll say init require frames is not empty. That will break. And now we're forced to not pass an empty list. Note that we've got an awful lot of value out of 2 tests so far, and thinking through the type system consequences. I'm just going to put those on separate lines, and I'll do the same here. Now, back up here then, where were we? We were saying that we need not to pass an empty list into here. So what should we pass? Well, I guess we should pass 10 frames, and as this is a brand new game, they should be unplayed frames. Now, Kotlin has an interesting way of doing that. We can call list, passing at the size we want, which is 10, and a block to initialize each element. So what do we want for each element? We want an unplayed frame. Goodness, that compiles and passes the test. Good. Make it a bit easier to see by putting these on separate lines so that we can scroll that way. And now it seems to me that this is really a constructor on playable game. So I think I'm going to add in a constructor here that itself takes a vararg of playable games, which we now know is going to have to be string, and that wants to invoke the primary constructor with this expression here. So we'll take that and put it in there, and now we can say that this is playable game with the player names. And I think we have to splat those. We've got a lot of value out of 2 tests, plus the types. I'm wondering if we just sanity check here, if we inline that, then we can check that the same is true for 1 player. I have reasonably no doubts that it is. And I'm right, that's good. Let's now do something with our playable game. So I'm going to duplicate test. And this is going to be play a game. So we'll pull out Fred and Barney as our game. We now want to see what happens when we roll some pins. So in here we can say game.roll. Except that we can't, because our type system doesn't know that the game we get back from Fred and Barney is playable. Strict knows, but that assertion hasn't made it through our type system. Interestingly, we could use Kotlin test assertions. So we could say assert true, game is playable game, and now game.roll would exist because of contracts on assert true. So let's use that information, and we'll say roll a pin count, and let's roll a 1. Now we know that we're not mutating our game, we're returning a new one. So for now we'll just say val game, I'm going to call it game 2, but it's the second view of our game if you like. And again, if we look at the return type of this, that's just game. So every time we roll on a playable game, we're forced to check that we still have a playable game. Now in return for that check, once the game is completed, there simply isn't a roll method on it, and so we can't call that when a game is finished. So we can do the same thing here, and we can say that game 2 is a playable game, and therefore we could say the game state 3 is roll another 1. Let's see what happens when we run these tests, by the way. And the answer is we get an operation is not implemented at 29, and that's our what is our current line expression here. Okay, we need to find a way to implement this. Now working out whether we've got that right might involve playing a whole game. So what I propose to do is to make the playable line visible to the tests. And the way I propose to do that is by exposing the current player name. So if we were to say here, we start with a game, and then expect that game.currentPlayer is equal to Fred. Now that doesn't exist, so we can make it a property. Now IntelliJ is proposing that we make it a property on game, but in fact I think it's a property on playable game. Again, a completed game won't have a current player. So we can hint that, I think, by moving that assertion up. Now maybe we'll get, yes, there you are, look, playable game, current player. We're going to put that on playable game. And we haven't admitted really to player name as a type, so I think the type of this thing is going to be string. Now I'm back in TDD mode. I think I'm prepared to fake it till I make it. So the current player, we get that by saying lines first dot player name dot value. And I seem to have messed this up here. That's going to be, ah yes, we can just import that. It's all very well having faked it though, but we're never going to be able to run these tests for a while because of this to do. So I think this is in fact current line player name. Current line doesn't exist, so we will create a property for that. And we know that's going to be a playable line. And to get it, well, we don't know yet, so we can do that. But that is this here. So in fact, we can say that's this current line down here. Now then, because we're building from the top down, I think it's going to be quite a time before this test gets to pass. Because we've got to go through this to do here in order to call this role. But this role is itself going to call playable line role, and that's got its own to do in it. I hate having broken tests. So what I think I'm going to do is I'm going to go up and fake it a bit at the top and then go down and implement playable line with some tests. So the tests don't pass. Now go back up here and say it will be enough to get us passing just a tiny bit if we say that our current line is lines.first. And we'll have to cast that to playable line. That will make the first of these things true, and then we can comment those out, and I think pass. Okay, let's go and write some tests for the line, and then come back up to game when we're finished. So I'm going to write a test for line. Our line is a playable line with a player name of Fred, and now we have a list of frames. We said it can't be empty. Let's just create ourselves list of an unplayed frame and another unplayed frame. So only 2 frames. And we think that that must be a playable line, line 2. Let's run to discover that we have this to do in playable line. So what is the playable frame in a playable line? Well, I think actually it's just the first playable frame in the list of frames. So we could say this is frames, find, it is playable frame. Now not all frames in a playable line must be playable, but at least one must be. Because we have all completed frames, that's when we create a completed line here. So we know this must find one, so I think in fact we can just cast this to as playable frame. But we can also say in here, require frames any it is playable frame in order to be constructed. Okay, how does that get on? We've got another to do. Where's that? We didn't implement replace one item in list with another. These parameters have these names because we extracted this when we had lines. I think this is replace item with new item. And replace is not necessarily a good name. I think maybe it would be list replacing, because replace implies in place. So I'm going to say replacing. Okay, how do we do this? Well, we could create a mutable copy of our input and then mutate it. But a reasonably cute trick is to say this is map, where the element we map to is if it is item, new item, else it. Now that will replace every item that is the same as the input item, but that may be okay. Let's see how we do. Okay, we passed some tests, good. I really want to know how well we're doing, so what I think I'm going to do is I'm going to say what happens if we had a playable line of only 1 frame. In that case we'd better roll once and get a playable line. And then if we rolled again, then we'd expect our line would be unplayable. Completed, in fact. So we'd expect line 3 is completed line. Is that true? No. But Duncan, you're an idiot. You rolled here. Line 2 was line 1, but line 3 should be rolling on line 2. Try that. Still not good, but we've changed the error now. We failed a requirement here. Bowling 56. We've created a playable line when there are no playable frames. Well, this assertion paid off pretty quickly there, didn't it? I suspect our issue may be here. We wrote this without any tests and we're pretty much guessing last time. Here we're saying that our line remains playable if we have less completed frames than the total frames. I think a better way of putting that might be that it is not playable if all the frames are completed. So that's sort of reversing that test like that. Let's do that. No, still not. Just actually look at the code. Ah, look here. We should be using new frames in here. Is that true? Yes, of course. So in fact, we could take that out and see that we're saying our completed frames is all of our new frames that are completed. Good. Well, now we've seen that playable line works, I wonder if we could play a game with just one player. Let's duplicate this here. Play a game with just one player. And the reason I think that might work, if I take that out, is that our only remaining to do, or place where we know we really have just faked it, is here lines first. But in a game with only one player, we only have one line, so that's actually correct. We'd have to roll a lot of balls to find out though, so I wonder whether we can change the game constructor to take the number of frames we'd like to play. So if I say here we want frame count equals 1, that doesn't exist, so let's add it. And apart from some strange imports there, and there, we should be able to default that to the 10 frames in a normal game. These have all now been replaced with invoke. Very strange. No, not that. Don't know what IntelliJ just did there. I'm going to take that out. And that. And that. Goodness me, what a mess of a refactor that was. Okay, so if I pass the frame count in here, we would need to pass it into playable game here. So I'm going to put frame count into there, add a second parameter to playable game, which is the frame count. I don't know what happened there either. But here we can use frame count in there. Now I think that everything that was passing should continue to pass, and does. And now our player game with just one player, which is here, we can say the game's current player is Fred. Now we step on to the second game state. It is a playable game and the current player should still be Fred. And now if we roll again, remembering to change that to be game 2, now I think we expect the game is a completed game. And that should be game 3. Let's see. Oh, we have a failed requirement here. Where's that? Bowling. And again, we had this issue about line. It is playable line. And again, I suppose we had the bug here that we needed to use new lines in there. Well, at least I'm consistently rubbish. Great. Let's change this test again, same way as we did before, to say that, and then reverse those. Is that true? It is good. And now I think really we only have one to do left, apart from a lot of testing that is, and we could express that I think in here maybe as our current line is lines single or null, and if we say as question mark playable line, then we can also use the Elvis to say this is our to do for handle more than one player. Is that true? And it is, because the place that we're breaking is here. Okay, I think we should disable this test as work in progress, rename this one as play a game with just one player and one frame, run that, and now let's check that in. So this is had tests and logic except for multiplayer. Phew. Thinking it through, the structure of our types has survived contact with the tests, that's good. The basic algorithm of what happens in roll, apart from a detail where I basically mistyped, has survived as well, suggesting that being guided by the types has been quite helpful. We haven't of course seen that we were correct at the frame level, where we have unplayed frames and in progress frames and strikes and normal completed frames and so on. So we still have a bit to do, and I think our tests would be improved if we could visualize the game in some sort of way. So I think that's where we'll start next week. If you'd like to see that episode, then please subscribe to the channel. Do the thumbs up thing, and maybe even buy the book that I wrote in that price called Java to Kotlin, a Refactoring Guidebook, details of which are in the show notes below. Thanks for watching.